الآن نشاهد فيديو للجلايكول ديهايدريشن، أي التجفيف الغاز بواسطة سائل الجلايكول. راح نتابع هذا الفيديو. هذا الفيديو مترجم، والحكي اللي موجود به هو كله احنا ذكرناه سابقا، بس فقط عمود لزيادة الفهم ولاستيعاب المادة أكثر. بس هنا أكو شغلة بالترجمة شوية يعني غلطانين بتسمية الجلايكول. يعني هو الداي الثنائي هو دا يسميه أحادي، والثلاثي دا يسميه رباعي، فشوية عنده بالترجمة فقط. يعني هو الإنجليزي دا يحكي صحيح، فقط بالترجمة عنده التسميات الجلايكول عنده بيه خطأ، فإحنا نعتمد على المكتوب بالإنجليزي هو الصحيح، ونعتمد على المادة مالتنا الجلايكول الثلاثي ليكون هو أكثر شيوعا واستخداما. الجلايكول الثلاثي أكثر شيوعا واستخداما. والآن أرجو منكم مشاهدة الفيديو.
Glycol dehydration processes and presents methods for specifying and sizing glycol units. Produced natural gas often contains water vapor. When water vapor in gas lines cools, it forms hydrates, a crystal-like compound of hydrocarbon and water, which looks like dirty ice. When hydrates form, they accumulate in valves and fittings, thereby blocking or restricting gas flow. Hydrates can also cause physical damage to equipment. Slugs of hydrates moving through a pipeline can produce high-impact forces at valves, orifice plates, and other line restrictions. Moreover, water condensing in a gas stream can cause corrosion, especially if the gas contains carbon dioxide or hydrogen sulfide. Also, water in gas lines reduces the line capacity, increases the pressure drop, and can produce undesirable or damaging slugging in pipelines. To eliminate such problems, gas sales contracts usually specify a maximum amount of allowable water vapor in the gas. The process of removing water vapor from a gas stream is called gas dehydration. In the petroleum industry, the most common method of removing water vapor from gas streams is glycol dehydration. A typical glycol dehydration unit consists of an inlet separator, glycol contactor, glycol reboiler, glycol pumps, filters, and a heat exchanger. Wet gas enters through an inlet separator, where any free liquids are removed before going to the glycol contactor. The gas enters the bottom of the glycol contactor and flows up through the vessel, exiting at the top of the tower. Dry or lean glycol enters the top of the tower and flows down through the vessel, exiting at the bottom of the contactor. The glycol and gas are mixed on the trays, as they flow counter-current to each other. As the glycol flows down, it picks up water from the gas and becomes wet or rich glycol. The wet glycol leaves the tower and goes through filters to remove solids and dissolved hydrocarbon traces. Then it enters a heat exchanger in the reboiler, where the water vapors are driven off to the atmosphere. The hot regenerated lean glycol goes to a storage tank, and from there to a heat exchanger, where it is cooled. Then it is pumped back to the top of the contactor, and the process repeats. As the wet inlet gas enters the contactor, the water vapor is removed as the gas flows up the contactor and is mixed with the glycol. The gas becomes drier as it goes from tray to tray up the contactor. The dry gas finally leaves the contactor through the top of the vessel. The types of glycol that are commonly used in dehydration units are diethylene glycol, triethylene glycol, and tetraethylene glycol. Diethylene glycol is the least expensive, but it cannot be regenerated to a high purity as the others. Tetraethylene glycol, also known as TEG, is the most commonly used type. In sizing a glycol dehydration unit, several design parameters need to be considered, including glycol concentration, number of trays, glycol circulation rate, and equilibrium data for TEG water vapor solution.